simultaneous equations, okay? When you see this will blow your mind away a little bit, okay? 2x plus 3y equals 29, x minus 2y equals negative 3, okay? Obviously you can solve those using an algebraic method, pretty easy, okay? That's not the point of the example. The point is to show you how you can use matrices to do it, okay? I'm going to rewrite the simultaneous equations like this, and as I'm doing it, try and work out why it works, all right? Yeah? Why does it work? Well, think about the matrix multiplication. When you do this matrix times this matrix, that row times that column, 2x plus 3y, and the answer is 29. 2x plus 3y is 29. Yeah. And then the next row, 1x subtract 2y equals negative 3. X subtract 2y equals negative 3. Ta-da! There you go. So, what can you deduce from that? Means you can write any, and I mean any simultaneous equations question in matrix form. Okay? Which makes it rather useful. Okay, so matrices are used to solve some really difficult simultaneous equations problems. Okay, I'm not just talking about with x and y. I'm talking about with 5, 6, 7 n variables in it. Okay, what's the method then? How do you solve these simultaneous equations? Well, you need to find the inverse of this. Okay, you need to find the inverse of this. So let's just do that. Okay, so if I call that matrix, I'll tell you what. No, I'll just write. Yeah, I'll do it. It's handy if I just say that's matrix A, and then for inverse A is rather than writing out in words. Okay, so the inverse of this then, so that's going to be, so it's negative 4, subtract 3, so it's negative 7. So the term is going to be negative 1 over 7. And the inverse, let's not mess this one up this time. Let's swap those two over. So negative 2, 2, multiplies by negative 1, negative 3, negative 1. Just make sure I'm not mucked it up. There we go. Okay. So that's the inverse, okay? And what we're going to do is we're going to multiply this side here, look, by A inverse, okay, there. And we're going to multiply this side by A inverse there. I've not left enough room to squeeze it on, okay, but we're going to do that. So we're going to multiply the inverse there by that, okay? So negative 1 over 7, negative 2, negative 1, negative 3, 2, multiplied by this, 29, negative 3. And let's just see what happens, shall we? So, actually, yeah, keep the negative 1/7 there. And I'm expecting that to be my answer, just like a vector, okay? So, that's going to be negative 58 plus 9. Oh, great. So, that's negative 49, which is nice, because that will divide nicely by 7, won't it? And then here, that will be negative 29. Subtract 6, it's negative 35, which is lovely again. So that means if I divide those by negative 7, that gives me 7, 5, okay, as my matrix. And that corresponds then to x equals 7, y equals 5. Because if you think about it, if I multiply the left-hand side by the inverse, I'm left with that times that as the identity. So x, y will be equal to, and I've worked it out here, 7, 5. So x is 7, y is 5. Let's just check that, okay? So 7, 5, so 14 plus 15 is 29, yep. And 7 subtract 10, negative 3, yeah, again. Okay, so that's kind of nice. Do you want to do another one? Yeah, of course we want to do another one. Of course we want to do another one. So let's just rub that off and write down another one, okay? Incidentally, I prepared these before I started recording. And the answers are integers, so I'll know if I've got them wrong if I don't have integers. Okay, so 5x minus 2y, 5x minus 2y is equal to, what do I say, 11. And then 2x plus 3y is negative 7. And just take a moment to check I've written them down properly. Yeah. Maybe you just pause the video and have a go, see if you can do it. It's quite easy. Maybe you've done that and you're just waiting for me now. So let's have a look. 5, negative 2. So you can see what you do. You just take the coefficients, don't you? The coefficients of each of these terms. Just make sure it's written in, well, in this case, alphabetical order. Okay, so the x term, the y term. Okay, so 5, negative 2, 2, 3. And then you've got xy. Okay, and then equals, and then here you write it as 11 negative 7. Okay, and then what you want to do is you want to find the inverse of that, and we call it matrix A. So inverse of that is going to be, so 15 plus 4 is 19, so 1/19. I said the answer to integers, so I'm just hoping that when all is done, the answers I get will be divisible by 19. Okay, and then swap those over. So 3, 5 multiplied by -1, so 2, -2. And let's have a go at doing this. Okay, I'll tell you what, to save it a space, I'm just going to sort of keep that there rather than write it again and say, look, I'm just going to then say that multiplying the left hand side, I'm going to end up with that because inverse times that gives the identity. So I'm going to get xy on the left hand side, and the right hand side, I'm just going to do this, aren't I? 11 negative 7. So that might be a slightly better way of showing my working. So 1/19, and let's go then. 33 subtract 14. 33, 29, 19. Yes, because I wanted a number to fill 1/19, didn't I? And then negative 22 subtract 35. Negative 22 subtract 35. Negative 35. Negative 57. And yes, again, that's divisible by 19. So that gives me 1 negative 3. Okay, and that's xy, of course. So that means I've got x is equal to 1, y equals negative 3. Are you enjoying simultaneous equations more now, seeing this? It's kind of fun, isn't it? Kind of cool. Okay, we'll just check those work, of course. So 5 plus 6 is 11, great. And 1 subtract 9 negative 7, also great. Okay, so that's that. Okay, so where do we progress from here? Obviously, we look at 3 by 3 matrices. Okay, and then I'll give you the simultaneous equations with x, y, z. Now, when you've got simultaneous equations with 3 unknowns, 3 variables, it does become harder to do algebraically. Okay, those are easy. In fact, you'd use the algebra approach to solve those, if I'm honest. Okay, but I'd rather show you how it works with 2 variables first. So with 3 variables, it's easier. The only thing is find the inverse of a 3 by 3 matrix. That's not easy. That's not easy. Okay. Coming right up in the next video.